Hello friends, continuing with the topic electric field. Today we take up another article, electric field intensity due to a uniformly charged circular loop of wire at any point on its axis, passing through its center, perpendicular to its plane, at a distance x from its center. So you mark so many technical points are there. Okay. Now first we develop physical situation. Consider a uniformly charged circular loop of wire of radius a having linear charge density lambda such that total charge on the loop, say q, is equal to lambda into L, where L is equal to 2 pi a. Let there be a point P on the axis of the loop passing through its center C, perpendicular to its plane, at a distance x from its center, where electric field intensity is to be determined. So it is a point P where we are to determine electric field intensity. Now we go to second point. Consider small length element dl of the loop at point S such that small charge on it be, say, dq equal to lambda dl. So this is the length element dl at point S. So small charge dq is equal to lambda into dl. That will be on this small length element. The third point, small field dE at P. dE at point P due to the small charge dq would be, say, dE equal to k naught dq by r square, where r is equal to under root x square plus a square and will be along pz. Now fourth point, dE can be resolved into two components, dE parallel equal to dE cos alpha along px and dE perpendicular equal to d sin alpha along py. Here this is px direction, this is py direction, so you can mark the directions also. Now fifth point, electric field at P due to whole loop. So we are to find out electric field due to whole loop at point P. Now consider perpendicular component dE equal to dE perpendicular equal to dE sin alpha. Electric field due to all such components for the whole loop add up to 0, because there would be an equal and opposite length element resulting into equal and opposite perpendicular component of the field, loop being symmetrically placed about its axis. I repeat, electric field due to all such perpendicular components for the whole loop add up to 0, because there would be an equal and opposite length element resulting into equal and opposite perpendicular component of the field, loop being symmetrically placed about its axis. Because loop is symmetrically placed about its axis, so there will be equal and opposite length element which will generate an equal and opposite perpendicular component which will cancel in pairs. Okay, so now we go to parallel component. Now consider parallel component of electric field dE parallel equal to dE cos alpha. Consider this component. Now, since all such components due to whole loop are directed along axis of the loop, Therefore, electric field due to these components can be obtained by integrating this field for the whole loop, that is, within the limits L equal to 0 to L equal to 2 pi. Therefore, integration dE parallel is equal to integration L equal to 0 to L equal to 2 pi dE cos alpha, r equal to 0 to L k naught dq by r square into x by r. K naught dq by r square is dE and x by r is cos alpha. So we substitute the values of dE and cos alpha. Therefore, we get integration dE parallel equal to k naught dq by r square into x by r. Now we substitute the value of dq as lambda dl. So we have the expression now integration 0 to L lambda k naught lambda dl by r square into x by r. Or we can simplify it, we can write it as k naught lambda x by r cube into integration 0 to L dl. On integrating dl, we get L 0 to L limits we put behind L now. So E parallel is equal to k naught lambda x by r cube into L limit 0 to L. So evaluate the limits as L minus 0, because how we evaluate limits, we put upper limit minus lower limit in place of L. So we have k naught lambda x by r cube into L minus 0 or equal to k naught lambda x by r cube. Now lambda L we can put it as q, because E parallel now is k naught lambda L x divided by r cube. So lambda L we put it as q, so we get now k naught qx by r cube. Now substituting the value of r is equal to x square plus a square under root. So we get E parallel equal to k naught qx divided by x square plus a square whole power 3 by 2 in denominator. Okay, so thus we get the expression for electric field due to the whole loop, and the direction is along axis of the loop, directed away from center of loop at point P. So this is the expression for electric field at any point P at a distance x from the center of the loop, passing through its center perpendicular to its plane. Okay, so E parallel is equal to k naught qx divided by x square plus a square power 3 by 2, direction along axis of the loop. Now discussion part of it. E parallel is equal to k naught qx divided by x square plus a square power 3 by 2. When point P lies at infinity, then x approaches infinity and E parallel becomes 0. Now when P lies at the center of the loop, then x approaches 0, then E parallel is again 0. Third point, when point P lies at very large distance, that x is very large as compared to A, then A can be neglected in denominator, then E parallel will be equal to k naught qx by x cube, or it is equal to k naught q by x square, or E parallel will be equal to k naught q by x square. So this is the electric field intensity due to a point electric charge at a distance x r from it. Okay, so this expression shows that this is the electric field intensity due to a point electric charge at a distance r from it. Thus, it can be concluded that A uniformly charged loop of wire at very large distance behaves as a point electric charge. I repeat, thus it can be concluded that a uniformly charged loop of wire at very large distance behaves as a point electric charge. Now, assignment 1.3 continued. Question number 13. Derive an expression for the electric field intensity due to a uniformly charged loop of wire at a point on its axis passing through its center perpendicular to its plane at a distance x from the center of the loop. At a distance x from the center of the loop. Show that the loop at very large distance behaves as a point electric charge. So this is the question, almost article that you have done above. So you have to derive the same article under this question. Thank you so much.